So, next question. We want to try some problems using parallel lines and corresponding alternate and vertically opposite involved in the calculation. Suppose I have a triangle and I have parallel lines running across it. Okay, and I'm told a little bit more information. So we know that this is parallel lines, and we're given that this angle is 130 degrees. We asked to find angle A. We also told us there's a block here, if you can remember what the block means. Okay, so this is geometry, and we're doing parallel lines. You can call these riders or rider questions. Sometimes you can call that, okay, so riders. This is A. These two are parallel lines. I want to find out what is B, then I want to find out what is C, then D, then E. And then lastly, yeah, I think those would be the main ones. Okay, so let's jump into this. The only thing I'm given is this 130 degrees, which is on the outside, and I can see that angles on a straight line add up to 180 degrees. And so I can say, well, A plus 130 degrees is equal to 180 degrees. And the reason would be angles on a straight line. So I've got angles on a straight line is equal to 180 degrees. And so therefore, A equals 50 degrees. And so this angle here, A, will turn out to be 50 degrees. Once you got an angle, put it in the diagram so that you can see more. Your brain automatically will start realizing that further answers will start coming naturally if you do this. Okay, so now we got A equals 50 degrees. Automatically using from A going forward, I can see B is going to be 50 degrees as well. All right, so let's see. B is equal to 50 degrees. Let's choose a different color. So B equals 50 degrees. This angle over here will be 50 degrees because of corresponding angles. Okay, we can see that over here, if I have to highlight it, remember this angle over here is equal to this angle over here because they correspond. Over here, you can see they're in the top left-hand side of the crossing of the lines, the crossroads of the lines. So B equals 50 degrees. You mustn't forget the reason. The reason is corresponding angles. Corresponding angles. And you can also state parallel lines because it doesn't exist unless there's parallel lines involved. Now, this block over here, if you didn't know, means 90 degrees. And the next thing is we have a triangle, and if you knew, angles in a triangle add up to 180 degrees. So I've got C is equal to 180 degrees minus 90 minus 50, right? Because angles in a triangle is equal to 180 degrees. And so C will equal, what's 90 plus 50? 140. So C will equal 40 degrees. And it'll be angles in a triangle equals 180 degrees for that. Now you have to use C to find D. You have to use C to find D. And D is on a straight line, so angles on a straight line will add up to 180 degrees. Angles on a straight line will add up to 180 degrees. So C, by the way, is equal to 40. Let's put it in our diagram. And again, we've got angles on a straight line. So that's going to be D. And so D will equal 180 minus 40, which is equal to 140. And the reason is angles on a straight line is equal to 180 degrees. And we keep writing these reasons, whatever reasons we need for each one. D equals 140 degrees. To go from D to E, you can see we have an alternate angle scenario here. We're traveling on a road, and suddenly we need to take an alternate route. And so we create alternate angles. And from here, you can see that this angle here is going to equal that angle there. Using alternate angles, my final part for this is going to be E is equal to 140 degrees. And the reason is because of alternate angles which are equal. Okay, alternate angles which are equal for that. All right, and we'll stop there.